In this video, we're going to make a comparison between limits and linear approximation. So let's say you've got a graph y equals sine of x. It will look something like this. We can approximate it near x equals 0. We can approximate it to a straight line. The equation of this straight line will be in the form of y equals mx plus c. It will be in this form here. We need to know the gradient. Well, the gradient is given by this. Near x equals 0, well, we can put 0 into here. So the gradient will be 1. So this thing here will be 1, blah, blah, blah. We've done this before. The near x equals 0, the best linear approximation would be this equation here, y equals x. So if you have a graph, y equals sine of x, near x equals 0, the best linear approximation would be the equation y equals x. And we've done this before. So if you don't understand this, track back to one of the early videos. But what I'm trying to illustrate here is that near x equals 0, around this region here, near x equals 0, we can say that this is approximately this. We can say sine, so near x equals 0, we can say sine of x is approximately x. Now, if you look at the concept behind limits, take the limit as x tends to 0. That is really you. That is really you being in this region, because when you take a limit as x tends to 0, you are talking about x being something in the order of 10 to the power of, let's just say 999 here. So this number here is very, very small. It is around here somewhere. It is around here. So when you talk about limits, you are really being in this region near x equals 0. So you can actually apply this. So what this is saying is that let's say if you have sine, let's say 7x. Well, near x equals 0, sine 7x is approximately 7x. Is approximately whatever this is here. So when you're talking about limits, take the limit as x tends to 0. You are really thinking in terms of 10 to the power of minus 99999, a really small number. Well, this really small number is within this region here. It is near x equals 0. It is within this region. So whenever you take the limit as x tends to 0, you can apply this. So whenever you have sine something complicated, it is approximately that's something complicated. So for example, so whenever you have sine whatever near x equals 0, you can say it is this whole thing here is approximately this. This thing here is a lot easier to deal with than this thing here. So near x equals 0, this complicated thing here can become this. You can approximate it to this. So if you look at this, if you're trying to find the limit of this, you can actually say, well, the concept behind limits is the concept behind this x tends to 0. It is really x moving towards something in the order of 10 to the power of minus 9999. It is a really small number. So because it's so close to 0, you can use linear approximation. You can use linear approximation on this. Remember, linear approximation, sine u is approximately whatever this thing here is. So if you look at this here, let's use, because we are taking the limit as x tends to 0, we can't, it is this thing here, it is near x equals 0, so we can use linear approximation on this. Well, remember, this complicated thing here, using linear approximation, just this bit here equals this. Now use linear approximation whenever this thing here is near 0, near x equals 0, then this complicated thing here simply becomes whatever this thing is here. So now simplify this, so it becomes this. So this is us using linear approximation. Well, if you use Hopital's rule, it would give you the same answer. The point here is that the point here is that linear approximation is very similar to you taking the limit as x tends to 0. So You taking the limit as x tends to 0, it's really you being within this region. So you can use linear approximation. You could, if you want to, use quadratic approximation, which we will look at in the next video. Okay.